Does this feel like a good, you can kind of see what's going on?
That's a setup right there.
Yeah, I'm so smooth.
That was pretty sick.
Okay, so yesterday this was, our null hypothesis for this example was mu equals 15. No, mu was less than or equal to 15? Yeah.
17?
No. And our alternative was that mu was greater than 15. And our rejection region was whenever z was greater than or equal to. Everybody with me? Mm-hmm. Okay, and this is all done before I even start my test, right? This is me just setting up and saying like what, based on the fact that we want to use that 20% alpha, and these were our initial hypotheses, okay? Then once we set that up, what we do is we take the actual sample. Is everybody with me? We take that actual sample and and we decide, does that sample fit inside that rejection region or not? Okay, so things that are important. This is n equals 20, and this 17 is not a mu. It's the mean of a sample, which is 15 or 17. Okay, you guys. Does this sample suggest that the actual mean is greater than 15?
Yes.
Does it convince us that it is greater than 18? Remember we're kind of like, what's enough to convince us to make us guess that greater than 17 or greater than 15 is actually correct? And the answer is, what we do is calculate a z-score for this sample. And we say, does this z-score lie in that rejection region? Everybody good? Mm-hmm. Okay, now, there's a formula for z-scores. This formula is on your formula sheet. And for the means, it says you do x bar minus mu divided by the square root of, I'm going to stop talking for a second. Now, we talked about it yesterday. One other component that we have. Okay, so if I want to calculate the z-score of this sample, the x bar, I'm going to use the mean of the sample, 17. The mu I use in this formula is going to be the number in the null hypothesis. And then I'm going to divide by 3.2 divided by the square root of 20. It was the population standard deviation that was given in the previous page.
Okay.
And it would, if you're using AZ, it would be given to you in the question.
Okay.
Everybody good?
Yep.
You guys. Remember, so the basic premise here is we have two possible hypotheses. Okay? And what we're kind of doing is saying, well, is it possible we could get 17 far enough from 15 to make us say, yeah, that alternative hypothesis is correct? Okay? And if my z is in the rejection region, that means I can say that the null hypothesis is not correct. And I can reject the null hypothesis and conclude the alternative. So it's always going to go like this. If z is in rejection region, That means we reject. And if I reject the null, I can conclude the alternative. So, in this particular case, is my z in that rejection region? Yeah. 2.795 is, in fact, greater than 0.842. Is that pretty good?
Yeah.
So, what decision am I making?
The alternatives.
Okay, so we can reject H0. And then the alternative you're going to state in context. So we're going to say the actual mean weight of mice is more than 15 grams. Because that's what my alternative said. All right, so when we look at part B, our null hypothesis, if we go back a couple examples. Less than 1.645. Okay, so this is how we calculate the z-score for means for the p-hats, or for proportions, we do p-hat minus the p of the null hypothesis divided by the square root of p q over n. And again, that formula also on that formula sheet. What is our p-hat? It's not the 122, but you're close. It's 122 out of 350. It's the proportion. It's the percentage. You guys, what is one? I don't know what that is. Roughly a third, a little bit more than a third, 35% maybe? 0.348? That was close. Okay. All right, so now to find that z-score, we do 0.349 minus 0.4 divided by the square root of. Now, you guys, we have for these ones, we use the null hypothesis to find p and q. Okay, so this would be 0.4. If p was 0.4, q would be 0.6. Remember, p and q always have to add up to 1. Okay, over, what was my sample size? 350. You got what? So, you guys, are we going to reject or fail to reject?
I'll reject.
Because
It's less.
negative 1 point. So I would expect to see something along the lines of negative 1.964 is less than negative 1.645. This was negative. I just forgot to carry the negative from the previous page. Okay. But it's still, negative 1.9 is less than negative 1.6, right? Okay, so we're going to reject and say the actual proportion of people who shower in the morning, or is less than 0.4. Now, that being said, there are shortcuts. There are shortcuts to finding your test statistic, just like there were shortcuts to finding your confidence interval. Less than 0.4. Okay? So, in your calculator, wait, is this showing? What's going on? Okay, so somehow I accidentally turned recording off and then it goes wrong. Okay, all right. So, if you hit stat and arrow over to test, just like when we did with a confidence interval, you will see z-test, t-test, one prop z-test. Okay, so this is a shortcut where you can just use this to calculate your test statistic. Now, your homework will probably have questions on it where you still need to be familiar with calculating it by hand. Okay? So, let's go ahead and do the one prop z-test. And the first thing it asks, it has a p and then a subscript 0. It's asking what was the proportion that you put in your null hypothesis. So what are we going to put in there? 0.4. And then our x and n will be our number of successes and number of failures, just like when it was the interval. So it was what, 122 out of 350? Then it's going to ask you what direction is your alternative hypothesis. So since this was a less than, we're going to go less than, okay? And then if you just go down to calculate.
Brown.
I'm sorry?
Oh, I just went to color brown. Oh,
And you'll notice we've got the exact same z-score, yeah? So this is another way to get to your z-score. Everybody good? These calculator shortcuts, guys, can do your calculations in no time whatsoever.
Wait, where do you get how do you get this in? What's it?
You stat, arrow so that tests is highlighted.
Oh, okay.
And so it's everything in this unit, and frankly, pretty much the rest of the year, sort of, with one exception, I think, will be in this, either this or using inverse norm or inverse t. Okay? Everybody good? Do you see your test statistic? Oh, well, I don't have mine showing it yet. Okay. And likewise, if I chose just a z-test at the beginning for the first question, we had the summary statistics. The mean of my null hypothesis was what, 15? My population standard deviation was 3.2. My x-bar was 17. My alternative was greater than. Same z statistic. Is everybody feeling okay with this? Okay, so let's look at this last one. So this one, the null hypothesis was mu equals 9. The alternative was mu is not equal to 9. And we said we were going to, when either t is greater than 2.733, or t is less than negative 2.733. And as we look at this, the information we're given is n equals 34. My x bar is 8.8. And the standard deviation of my sample is 1.3. Okay, so if I were going to go straight to the calculator shortcut, you guys, should I be using Z or T here? T. So I'm going to go to stat. I'm going to arrow over to tests. Which one do you think I should pick?
One,
We are doing a T test, yes? Do we have two samples? No, so you pick just T test. No. That's so annoying. I don't know why that keeps happening. So once you pick t-test, what's the mu 0 gonna be? 9. X bar is gonna be 8.8. S is gonna be
1.3.
And it's not equal.
change that alternative hypothesis to not equal to. Go down and calculate.
T equals negative 0.89. So
So it's good.
it is good.
So in this case, we are
Rejecting.
is this in my rejection region? Is it bigger than 2.7?
That's what we're
Is it less than negative 2.7?
No,
Okay.
it's true.
Now, you guys. It doesn't surprise me that this is a low t statistic, because look how close my sample mean and my null hypothesis are. Right? Like, as I look at this, I'm like, is this evidence that it's not equal to 9? Yeah, but is it convincing evidence?
No.
Not really. Okay? So, how does our conclusion work? If we don't have that, we're going to say t is not in the rejection region. We don't have enough evidence to say the actual mean car length. Is different from 9. All right, now, there's a different way we can make the exact same conclusion besides doing the rejection region. You're going to be expected to know both the traditional method, which is under what circumstances will we reject, okay? Another one is something called the p-value method, okay? And so you will notice that when we ran all these tests, whether it was this one, notice how we have a p-value? Okay? And then the previous one, all of them had what we call this p-value. Okay, and that p-value is the probability you could have gotten that sample. Okay? So if you are using the p-value method, everything in the calculator is going to be the same. You're going to do this to get to this point. Okay? And then what you're going to do is compare your p-value to alpha. So for example, for this one, we set alpha to be 20%. For this one, we set alpha to be 5%. For this one, we set alpha to be 0.01%. Okay? We did that on the previous page when we calculated the rejection region. Okay? So if your p-value is less than alpha, you can reject the null hypothesis. If your p-value is greater than alpha, which, by the way, this is the one that's greater than alpha, right? It was 0.37 or 0.38, something like that, right? Okay? If your p-value is greater than alpha, you fail to reject the null, and you don't have enough evidence to conclude HA. We feeling okay still? Okay. Like if we think about, we go back to this one, right? It's possible, especially with this, that the alternative is correct. It's just not possible, and like we just don't get to that conclusion based off of this sample.
But null ever exactly correct?
And again, I'm going to go back to this one. Our sample gives some evidence, but I would also argue that this is evidence that the null is correct because it's so close. It's different, so it's technically that the alternative is true, but that certainly seems within capabilities, and I'd be just as likely maybe to get a sample of 9.1. Okay. There's 4, even though when we run a test, there's 2 conclusions, there's actually 4 actual outcomes, okay? Because as we go through this, we start with our null and our alternative hypothesis. We could have that the null hypothesis is true. And if that's the case, should we reject or fail to reject? If the null hypothesis is true. Should we reject the null if it's true? No. So rejecting the null if it's true is an error, right? What about, but if I fail to reject, that's a good decision. Now, do I know that the null is true? Do we know that the null hypothesis is true? No. Will we ever? No. We make our conclusion based off of the data we have. And there's a correct conclusion based off of the data we have, but we don't know that our data is good data. Like, it's always possible, because samples aren't perfect, it's always possible that we get a sample that comes to the wrong result. That's not our fault. We didn't screw up as a statistician. That just is what it is. Okay? All right. Are our other possibilities that the alternative is true? And if the alternative is true and I reject the null, I'm going to conclude the alternative. That's a correct decision. That's what we want to make. Does that make sense? But if I fail to reject the null, in other words, I fail to conclude the alternative hypothesis, even though that alternative is true, that is also an error. Does this make sense? Now, another way of thinking these through, guys, think about the American justice system. Okay? What's our null hypothesis in the American justice system? Innocent. Right? We start off assuming somebody's innocent, and if we have enough evidence, we reject their innocence and conclude they're guilty. Okay? So you can look at this and see, HO is true means they're innocent, so if we send them to jail, that's a problem. Right? Okay? What if they're guilty and we let them go? That's also a problem. Those are two different mistakes. They are both mistakes. If we send an innocent person, or if we let an innocent person go free, that's this box. If we send a guilty person to jail, that's this. This is sending a guilty person, letting a guilty person go free. Do you guys see what I'm saying? They're two very different mistakes that the justice system could make. Okay. This type of mistake is called a type 1 error, where your test comes to the wrong conclusion because the null is true, but you reject it. Okay, so type 1 is you reject H0 when it's true. And type 2 is fail to conclude HA when it is true. So, you guys, in a pregnancy test, the null hypothesis is not pregnant, because that's like most people are not, right? And then the alternative is pregnant. Hence, if Lombardi tells Wappy that he's pregnant, right? That's a type 1 error. There's no amount of evidence in the world that's going to make Mr. Wapner pregnant. Everybody good? She is pregnant. He came to the wrong conclusion, yeah? He didn't conclude that she was pregnant even though she is. Kind of little, yeah. Okay. All right, so let's kind of go through how I might ask you about type 1 and type 2 error, okay? We want to show the average cost of tuition is less than $28,000 a year. You guys, what would my hypotheses be?
Tuition is greater than equal to.
I'm sorry?
The HO would be it's greater than
What is?
the HO.
Mu.
Or mu is.
Because it's mean. Yeah. Mu is greater than or equal to 28,000. You got the hard part. And the alternative would be? Mu is less than 28,000. Thank you. I'm not allowed to take my antihistamine gel. It's the worst time of year to not be able to do it. All right, type 1. Okay. So for type 1, we reject that and we'll conclude the alternative, right? So we're going to conclude the actual mean cost of tuition, or average cost of tuition, is less than 28,000 per year. Even though it isn't. We're making a mistake. Pretty much. Well, sort of, because we never really conclude that the null hypothesis is true. Because if we don't reject the null, we still have two competing hypotheses. Okay, because we usually have some evidence that the alternative is true, just not enough to convince us. Okay? So instead, we're going to fail to conclude the actual average cost. Even though it is.
So even when the alternative is correct, it's not definitely correct. Because you fail to conclude that it's not.
Even when there are times where the alternative is correct and we don't conclude that. Right? Into easy.
Or it's
Oh,
just
quite interesting.
within margin of error.
The null. Yeah, I mean, yes, it's possible if the null hypothesis is correct. It's very possible that, because, like, think of it this way. All right, I'm done.